Okay, so in this video, I am going to attempt to solve some Hackerrank problems in Python. During a recent live stream, someone requested if I would try to solve some of these problems. I did something similar, I think, a year or two ago with exorcism.io, which is a pretty cool website for getting some practice in. I'm going to do Hackerrank this time, and I'm going to solve some problems in Python. I'm going to set a half hour aside to do this, so we'll see how far we get. I've done some HackerRank problems in the past, but now I'm going to try to solve one that I haven't solved yet. And we'll just start out with some easy problems here. So let's start out with this birthday chocolate problem. I'm going to start a half hour timer, and we'll see how far we get. Okay, Lily has a chocolate bar. She wants to share it with Ron. Each of the squares has an integer on it. She decides to share a contiguous segment of the bar, selected such that the length of the segment matches Ron's birth month, and the sum of integers matches his birthday. All right, so given that we have some array of ints here, she wants to find segments summing to his birthday, which would be 4, with a length equaling his birth month, m equals 2. So we're finding sublists of length m which sum to d. And we're only finding contiguous segments, so they are just strictly sublists. And so in this case, there are 2 meeting her criteria, 2 and 2, and 1 and 3. So basically, it looks like, if I'm reading this correctly, we just need to create a sliding window across the array and find the cases in which the sum of that subarray is equal to some value. So what do we need as an output? An integer denoting the total number of ways that Lily can portion her chocolate bar to share with Ron. Okay, so yeah, let's create a slide. Let's try this sliding window idea, I guess. All right. So I'm gonna use Python 3. So D is the birthday. And D is the sum that we're looking for. M is the month, which is basically the window size of that sliding window. And what is S is the array of ints. All right, so we just need to keep track of the number of matches, which will start out as 0. And then we need a way to create a sliding window that we can slide across S and sum. So for n in sum range, what we're going to do basically is we're going to define our window size, which is that segment, and then just check if its sum is equal to, in this case, D. So we have some segment, which I'm not sure is yet, but we know that if the sum of the segment is equal to D, then our num matches gets incremented. And then ultimately we're returning num matches. Right? Where's the output? Print an integer denoting the total number of ways that Lily can portion her chocolate bar to share with Ron. So given a window size of 2, find all the ways that we can sum to 3. So there's 1, 2, and that's it. So our output is 2 in that case. All right, so to get our range, we have some list of ints here. And what I'm thinking is that we have some window that has some values in it, which is of length m, and which slides across a certain number of times. So what we need is for n in range. So the length of the array is just length of s, but we don't want the length because if we did that, our window would obviously overshoot the array that we're sliding through. So I think this needs to be minus, what's m? M is our window size, so m minus 1, I think, for range. And then the segment is that slice of the array. So it's some slice of the array from n to m. M is the window size. We need to increment we need to push the slice out each time we increment. So n plus m. When n is starting with 0, we get the initial window size. I think that this works. So anytime the sum of the integers in our window are equal to the days, we just increment the number of times we've matched. Okay, we're passing some test cases, which is good. Let's submit. All right. Cool. So that was just a sliding window problem. Okay, you're given an array of n integers and a positive integer k. Find and print the number of ij pairs where I is less than j and the array at index I plus the array at index j is divisible by k. So this sounds like we're going to do some mod operation to evaluate whether or not that's the case. So for example, if we have some array and k is equal to 5, our 3 pairs meeting the criteria are 1, 4, 2, 3, and 4, 6. So this, where the sum of I and j is divisible by k. I see. So 5 and 5 obviously go into 5, and 10 goes into 5. So the first line contains 2 space-separated integers n and k, and the second line contains n space-separated integers describing the values of the array. Okay. So to brute force this, we would just compare the number at every index in the array with every other number in the array. And we're only looking at pairs of numbers. So we would just sum those two numbers, mod by whatever the value of k is, and if it's 0, then that is a case in which the solution is valid. And so are we doing for output? Yeah, we're just incrementing the number again. So we'll just call this valids is equal to 0. And what's n here? Length of array. Array is the list, obviously, of ints, and then k is the where we need the mod of k to be 0. Okay. So what we can say is for I in range, length of the array, for j in range, we only need to sum numbers after the number that we're looking at. Then the sum of I and its pair, we need to find I in all of its pairs. Or we need to find, rather, all the pairs in the array. List object cannot be interpreted as an integer. Where is that? Int object is not iterable. Sum of I and j mod k is equal to 0. Oh, sorry. I need sum at array and array of I and sum at array of j. Okay, so we got a wrong answer here. I said 7 while the expected output is 5 for 6 and 3 as inputs. So what is the format of the input again? First line contains 2 space separated integers n and k. So n is just the size of the array, and k is the number that we need it divisible by. So in the case of this, there are 5 pairs divisible by 3, so we've got one and 2, which is 3, and then 1 and 2, which is 3. And oh, right. 6 and 3, which is 9. There are 5 valid pairs when k is equal to 3. 1 and 2, 1 and 2, 3 and 6, and then 2 and 1, and then the other 1 and 2. I see. So why am I only getting 5? Wonder if we can determine this. For I in range length of array, so let's put some debugging out here. So it's going 1 and 1, 1 and 3, 1 and 2, 1 and 6, 1 and 1, 1 and 2, 3 and 1, 3 and 3. So it's actually comparing. Wait, okay, 3 and 1, 3 and 3, 3 and 2, 3 and 6, 3 and 1, 2 and 1, 2 and 3, 2 and 2, 2 and 6. I see. I'm doing this part incorrectly. Alright, let's think about this. For I in the range, length of the array, for j in the range, length of the array I to the end, so when we take an example array like this, so like when I is equal to 1 here, then we say for j in range I see. Okay, let's give that a shot. That was ugly. For a minute there, I was getting confused by the fact that I was using range for the second value in the sum. So basically what I'm doing now is I'm saying for every number, for every index in the list here, and then for every number in the slice of that list, starting at the number after the current index up to the remaining end, if the value at that index plus that number and not the array at the index j is 0, or mod k is 0, then we increment valids. Okay, that took way too long. Hopefully we can get one more in. Okay, you've been asked to help study the population of birds migrating across the continent. Each type of bird you're interested in will be identified by an integer value. Each time a particular kind of bird is spotted, its ID will be added to your array of sightings. You'd like to be able to find out what type of bird is most common, given some list of sightings. Print the type number of that bird, and if 2 or more types of birds are equally common, choose the type with the smallest ID number. Okay. So that looks pretty straightforward, I think. First line contains n, the number of birds sighted. Second line describes an array. So we could use like a dictionary. We could use a dictionary here and get the minimum value. So let's see. We could make a sightings dictionary, and then for bird in array, could do a default dict with values of 0 for every key. But we could also say if bird not in sightings.keys. Might also just be able to say if bird not in sightings. If bird not in sightings.keys, sightings for that bird plus equals 1. Or sorry, is equal to 1. Otherwise, sightings at bird plus equals 1. And then we just need to return the type, the most common type, unless there's a tie, in which case we return the minimum value between the two. So this isn't super efficient to use a dictionary here because we're going to have to iterate through all of the keys and find like the lowest value. But let's brute force it anyway. We know we can have multiple lowest vals. So max sighting is 0, and then if v is greater than the max sighting, then the max sighting is set to k. If v is equal to the max sighting, all right, let's do this one step at a time. Let's not worry about the lowest val just yet. Basically, if v is greater than the max sighting is equal to k. I mean, maybe even like a hackier way to do this is just to say that the bird types are just the sightings. We basically need to like sort the dictionary by value descending So then if the value is equal to sightings at k, and if k is less than max sighting, all right, this is like super ugly and brute force. Oof. All right. So the expected output is 4 because 4 occurs 3 times in here. So let's step through the logic. So we have this sightings dictionary, which will have key value pairs, which are the type to the number of sightings. And our goal is to return the most frequent type. So for bird in our array, if the bird is not in sightings.keys, sightings of that bird are equal to 1. Otherwise sightings of that bird, oops. we add one. Okay, and then we set max citing equal to none for key values in our dictionary. If max citing is none, which it is at first, then our max citing is just for that the first bird that we see there. If the value at that case is greater than citings at k at that type, then the max citing is also equal to k. If the value is equal to the citings at k, oh, this is wrong. If the value is equal to, so when we have a tie, no, this is wrong. What am I doing? If the value is greater than the max citing, then we set that, and then also if the value is equal to the max citing, then we have to check if k is less than the previous k that we for which we saw. So it's not k less than max citing, it's k less than whatever that max citing was. So we could make this itself a dictionary. We could make it, yeah, we could just say bird num frequency 0. Otherwise, if the value is greater than the current frequency, then the max citing at bird is equal to k, and the max citing at the frequency is equal to the new v. If the value is equal to the max citing frequency and k is less than that value, then we also assign. Okay, let's try that. That's even uglier. Oops, and then we obviously need to just print out the bird. Okay. All right, so I went over the time limit. I'm not sure that I was really doing that well during this these 3 easy problems, but getting the gears turning again, getting a little warmed up. Hopefully I can make more of these videos. Hopefully I can do a better job being more efficient at creating algorithms to solve these problems. If you found this interesting, let me know. If you'd like to see more videos like this, or if you'd like to see me try this in different languages, I'd totally be up for it. It's kind of fun. Again, trying something different now and then. So thanks for watching. See you again soon.